Good day, people. I am Projam Elubidika, and today we will be explaining to you how to solve rational zeros theorem. But first, what is rational zeros theorem?
The rational zeros theorem is a method to help you find possible rational solutions of a polynomial with integer coefficients.
The purpose of the rational zeros theorem is for us to get the first zero, then use that to get the others. Here's an example by Pearl-Jam.
F of x equals x squared plus 13x plus 36 all over x squared plus 3x. The first step that we are going to do is to factor the numerator and denominator. So let us have f of x and let us have the factors of the numerator. Factors of x squared, that is x and x. And what are the two numbers? If we multiply, we can get positive 36. And if we add, we can get positive 13. And that is positive 4 and positive 9. 4 multiplied by 9 is equal to 36. And 4 added to 9 is equal to 13. Then, let us have the factor of the denominator. The greatest common factor between x squared plus 3x is x. X multiplied by x squared is x, and x multiplied by positive 3 is equal to positive 3. The next step that we are going to do is to identify the restrictions. The restrictions, those are the values of x that makes our function undefined. So let us set the denominator equal to 0, and that is x, quantity of x plus 3 equals to 0. So we're going to have x equals to 0 and x plus 3 equals to 0. Let us move positive 3 on the other side of the equation, so that is x equals negative 3. Therefore, the restricted values are 0 and negative 3. If we're going to substitute 0 and negative 3 in the given function, it will give us undefined. Next step that we are going to do is to identify the values of x that make the numerator equal to 0. So let us set the numerator equal to 0, that is, quantity of x plus 4 times quantity of x plus 9 equals to 0. And let us have x plus 4 equals to 0 and x plus 9 equals to 0. Let us move positive 4 and positive 9 on the other side of the equation. It will give us x equals to negative 4 and x equals to negative 9. Since negative 4 and negative 9 are not restricted value, therefore, the zeros of the functions are negative 4 and negative 9.
F of x is equal to quantity of x negative 5 squared all over x squared negative 25. To find the zeros of the given function, the first step that we're going to do is to factor the numerator and the denominator. So, let us have fx in the factored form of x negative 5 squared, that is x negative 5, x negative 5. Then, the factors of x squared negative 25, that is x plus 5, x negative 5. If you're going to multiply x plus 5 and x negative 5, it will give us x squared negative 25. Next step, identify the restrictions. The restrictions, those are the values of x that make our function undefined. So, let us equate the denominator equal to 0. Let us have x plus 5, x negative 5 equals 0. Let us move positive 5 and negative 5 on the other side of the equation. It will give us x equals negative 5 and x equals 5. Therefore, the restricted values are negative 5 and 5. If we're going to substitute negative 5 and 5 in the given function, it will give us undefined. Since we have the same value of x, we're going to have x negative 5 equals 0. Let us move negative 5 on the other side of the equation. It will give us x equals 5. Since 5 is a restricted value, therefore, the function has no 0, and that will be our answer.
For the next example, the given function is f of x is equal to x squared minus 9x plus 18 all over x squared minus 5x minus 6. The first step that we're going to do is to factor the numerator and denominator. So let us have f of x and the factors of numerator. Factors of x squared, that is x and x. And what are the two numbers? If we multiply, we can get positive 18. And if we add, we can get negative 9. And that is negative 3 and negative 6. Negative 3 minus 6 equals 18. And negative 3 plus negative 6 equals negative 9. factors of x squared, that is x and x. And what are the two numbers? If we multiply, we can get negative 6, and if we add, we can get negative 5. And that is negative 6 and positive 1. Negative 6 times 1 equals negative 6, and negative 6 plus 1 equals negative 5. And the next step that we are going to do is to identify the restrictions. So let us set the denominator equal to 0. So that is quantity of x minus 6 times the quantity of x plus 1 is equal to 0. Let us have x minus 6 equals 0 and x plus 1 equals 0. Then let us move negative 6 and positive 1 on the other side of the equation. It will give us x equals 6 and x equals negative 1. Therefore, our restricted values for this function are 6 and negative 1. If we're going to substitute 6 and negative 1 in the given function, it will give us undefined. Next step that we are going to do is to identify the values of x that make the numerator equal to 0. So let us set the numerator equal to 0. That is quantity of x minus 3 times the quantity of x minus 6 is equal to 0. Let us move negative 3 and negative 6 on the other side of the equation. It will give us x equals 3 and x equals 6. Since positive 6 is a restricted value, therefore the zeros of the function is 3, and that would be our answer.
Let's find all the zeros of this function. F of x is equal to x cubed plus 8x squared plus 11x minus 20. So we need to divide p by q. P is associated with a constant term. Q is associated with the leading coefficient. So let's list the possible zeros factors of the constant term p, or factors of 20. Factors of 20 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. And then, for the leading coefficient factors of 1, it's just 1. So let's start with 1. Let's see if f of x is equal to 0. So it's gonna be 1 to the third power plus 8 times 1 squared plus 11 times 1 minus 20. So 1 to the third power is 1. 1 squared times 8, and then this is going to be 11. 1 plus 8 equals 9. 9 plus 11 equals 20, and 20 minus 20 equals 0. So 1 is a 0. Therefore, we could say that x is equals to 1. And that's the first answer that we have. Now, let's use synthetic division. So the coefficients are 1, 8, 11, and negative 20. 1 times 1 equals 1. 8 plus 1 equals 9. 9 times 1 equals 9. 11 plus 9 equals 20. 1 times 20 equals 20. And negative 20 plus 20 equals 0. So then this is going to be 1x squared plus 9x plus 20. Now, let's factor it. What are two numbers that multiply to 20 but add to the middle coefficient 9? So this is going to be 4 and 5. 4 multiplied by 5 is equal to 20, and 4 added to 5 is equal to 9. So to factor, it's going to be quantity of x plus 4 and quantity of x plus 5. And let's set that equal to 0. So it's going to be quantity of x plus 4 times quantity of x plus 5 is equal to 0. Therefore, x will be equal to negative 4 and negative 5. So now, we have three zeros of the polynomial function: 1, negative 4, and negative 5.
Thank you for listening, and we hope you learned something.